Chapter 5 is about quadratic functions and their graph. So a quadratic function has an x squared term, and the quadratics are in the shape of parabolas. So a parabola looks like this. It's a U shape. It can open up or it can open down. It can be narrow, it can be wide. So the standard form of a quadratic is ax squared plus bx plus c. C is the constant. It does not have an x. So example 1, determine whether each is a quadratic or linear function. Identify the quadratic, linear, and constant terms. So I'm going to do the distributive property on here, and I'm going to have y equals 5x squared minus 40x. So the 5x squared is the quadratic term, and the negative 40x is the linear term. So I'm going to do the same thing over here. I'm going to do the distributive property. And when I do that, these 3x squareds will cancel out. Positive 3x squared and negative 3x squared will cancel out. So all I have left is a negative 15x. So it's no longer a quadratic. So this is a quadratic function, and this is a linear function. So just make sure you do the distributive property. So quadratics have a vertex, which you can find by doing opposite b over 2a to get the x coordinate, and then to get the y coordinate you plug in negative b over 2a. So this notation means basically you're plugging in negative b over 2a in for x to see what y is, because a vertex has an x and a y. The axis of symmetry is a vertical line, so it's going to be x equals that crosses through the vertex. So if your parabola looks like this is your axis of symmetry. It's a vertical line that goes through the vertex. And the y-intercept is 0c, where c was that constant. And the y-intercept is plug in 0 for x. So down here, identify the vertex and the axis of symmetry, and identify the points corresponding to P and Q. So the vertex right here is a spot, and the scale is going up by 1, so the vertex is at 1, negative 1, and so the axis of symmetry is going to be whatever the x value is, x equals 1. Then to find the corresponding P and Q is, you have to think of this as your line of symmetry. So if P is on the left hand side, P prime is going to be over here, equal distant from the axis of symmetry. So P prime is going to be this dot right here. So P prime is going to be at 3, 3. Q prime is going to be over here. Q prime is going to be at 0, 0. Over here I'm going to make the vertex, which is the scale is going up by 1, so the vertex is going to be at negative 1, 2, and the axis of symmetry is x equals negative 1, and then P prime is at 0, 1, and Q prime is at negative 3, negative 2. So graph each parabola, identify the vertex, the y-intercept, the axis of symmetry, and make a table of values. So if I'm looking at this parabola, I'm just going to talk about some facts about this parabola based on the equation. So I know that this parabola opens up because the coefficient of x squared is positive. I know that it's narrow, it's a vertical stretch because A is greater than 1. I also know the y-intercept is negative 5. So I'm going to find the vertex and do opposite b over 2a. So if I look, the b, there's not a b term, so b is 0. So it's going to be 0, plug in 0 for x, and you get -5. So the vertex is right here, and it opens up. So to make a table, I'm going to plug in 0, -5 in the middle of my table, and plug in numbers greater than or less than. So if I plug in -1, it's going to be -5 plus 3 times -1 squared. So that's going to be -2. And symmetry is going to be -2 on this side. So now I'm going to plug in 2, and it's going to be -5 plus 3 times 2 squared. So that's 4 times 3 is 12, minus 5 is 7. So here are my plots, -1, -2, and these -2, 7, and are way up here. So I knew it was going to be narrow. So my axis of symmetry is always an equation. So x equals 0 is my axis of symmetry. My y-intercept is 0, -5. So I'm going to do the same thing over here. When I do an opposite b over 2a, I get 0, plug it in, I get -4. When you're graphing and you're making a table of values, always put the vertex in the middle. Pick numbers that are less. And then I'm going to plug in -1. So when I get -2, which means 1 has to be -2 because of symmetry, and I plug in 2, so this is 4 and 4. So I plot the y-intercept is 0, -4. And 2, 4, -2, 4. So both of these parabolas open up because A is positive. Both of them have negative y-intercepts, and they both have axes of symmetry at x equals 0. So this slide just goes over kind of what I said about whether it opens up or down, how to find the axis of symmetry, how to find the vertex, both points. The y-intercept has to be the c value, and you can use this the axis of symmetry to find other points on your parabola. So if you know this is a point over here, this has to be equal distance, this works.